Well, hi guys. We're going to look at some examples of logarithms and exponential functions. And so this is a shout out here for Amanda. Amanda, I'm sorry that it took me so long, but this is your shout out today. And just wanted to let you know I appreciate how awesome you're doing in class, and I also like having you in class anyway. So that's your shout out. So we're going to be talking to all of the people that were the policemen or the policewomen in your projects, because you guys dealt with this formula, and I want to show you how to use this. And you know, this unit really has applications with what people really use in real life, and you will definitely use your interest formulas. You'll have to know this, and so I'm going to show you how these work. And it depends on how often your interest is compounded. And if it's compounded continuously, then we're going to be using our regular growth and decay formula, except this time it'll be A equals P e to the RT. That's the one that's typically used instead of the N equals N naught times e to the KT. This is your continuous compound formula. But if it's not compounded continuously, then you're going to need to use this formula that I have typed up here. And the y of t is the amount after t years. The y naught is the initial amount. The r is your interest rate as a decimal. N is the number of times it gets compounded in 1 year, and t is the number of years. And that's an NT up here. I hope you can see that. That is an NT. Let's work a couple of examples here. Alright, Sam is investing $5,000 into an account that earns 3% annual interest rate. If the bank compounds monthly, how much would he have after 5 years? All right, so let's identify some things. What does that 5,000 represent? And what's the 3%? And the compounds monthly, what does that mean in the course of 5 years? So the 5,000, that's your initial amount. That's how much money you put in. The 3%, that's your interest rate, so that's 0.03. Now, you compound it monthly. There's 12 months in a year, so they're going to compound it 12 times in that year. And then the time is 5 years. We want to know what is the y of t, so we're just going to plug this into our formula. Y of t is your initial amount times 1 plus interest rate over the number of times compounded raised to the nt power, and you just throw that in your calculator, and that's the amount right there. Okay, the next one is, what if it compounds continuously? How much would you have after 5 years? Now here we're going to have 5,000, our k is 0.03, and our t is 5. And we're plugging this into, you know, like the amount equals p times e to the RT power or KT power, either one. Or A equals PE to the RT. R is the growth rate, K is the growth rate, it's the interest rate. Alright, so you just throw that into that formula, 5,000 times E to the 0.03 times 5. And we get a little bit more money. It's not a lot, but it's a little bit more. So there is a difference. And for those of you that investigated the policeman on your web quest for the interest rate, you saw compound interest is actually gives you more money. Unless you borrow it, then you're paying more money. All right, let's do another example. If he had 6,000 in the bank, how many years has the money been in the bank if it was compounding weekly? Well, 6,000 would be the y of t, and again, our initial amount was still 5,000. Interest rate was still 3%. This time we're going to compound it weekly. That's 52 weeks in a year. And then we want to find out what is the value for t to make it grow to 6,000. So I think I've got this on the next page here. Now this one is going to require us to use logarithms. It's not just throwing it in on the calculator. You'll see here we've got it grew to 6,000. It started at 5,000. We compounded it 52 times, and we are looking for the value for t. So we're going to have to use logarithms. Now one thing that you want to do first, of course, is go ahead and simplify, divide both sides by 5,000. And I want you to know here you can take the natural log of both sides or the log log of both sides, log base 10 or natural log, it doesn't matter. Here I went ahead and showed you log base 10. So you can take the log of both sides. Of course, we know that the 52t can come down in front. And then I divided by all of this. This is just a number, the 52 and the log of 1 plus 0.03 over 52. and I type that in the calculator, and it's 6.08 years. So anyway, that's it. You're going to try some compound interest formulas tomorrow and some problems tomorrow, and I will see you then.